We are going to the 23rd question now. 23rd question, exercise 5.1, page number 160. Find all the points of discontinuity of f given by f of x is equal to sin x by x if x less than 0, x plus 1 if x greater than or equal to 0. Now, let us understand this function. After 0 and including 0, the value of the function is x plus 1. Before 0, the value of the function is sin x by x. So, we have to discuss the continuity of this function. So, obviously, we are going to split into three cases, less than 0, greater than 0, at 0. First case is less than 0. So, let C be any number which is less than 0. All these sums are of the same order. Let C be less than 0. Limit extending to C of f of x will be limit extending to C of sin x by x. Don't think sin x by x is 1. Limit extending to 0 of sin x by x only is 1. So, this will not be equal to 1. This will be equal to sin C by C. And what is f of C? F of C will also be sin C by C, because we are thinking of, because C is less than 0, we have to substitute it here. So, we have seen that the limit and the function value are both same. Therefore, the function is continuous for every x less than 0. Let us look at the case 2. Case 2 is x greater than 0. So, let C be a number greater than 0. So, again, limit extending to C of f of x will be equal to limit extending to C of x plus 1. So, that is going to be equal to C plus 1, because since x is greater than 0, we are going to substitute the value here as C. So, the value of the function and the value of the limit are both same. Therefore, the function is continuous for every x greater than 0. Now, the last case, x is equal to 0. Limit extending to 0 minus before 0, after 0. Limit extending to 0 minus of f of x will be limit extending to 0 of sin x by x, because before 0, the value of the function is sin x by x. And we know that from 11th standard limits and derivative, we have seen that limit theta tending to 0 of sin theta by theta is equal to 1. So, this becomes equal to 1. For the right hand limit, limit extending to 0 plus of f of x will be equal to limit extending to 0 of x plus 1. So, that is equal to 0 plus 1, that is equal to 1. So, limit is same. And what is f of 0? F of 0, here x greater than or equal to 0 is there. So, for 0 we have to substitute here. That is also going to be equal to 1. Therefore, the function is, value of the function and the limit are same. Therefore, the function is continuous at x is equal to 0. It is continuous before 0. It is continuous after 0. Therefore, the function is continuous for all x belonging to R. I hope it is clear. Question number 24. Determine if f is defined by f of x is equal to sin square into sin 1 by x for x not equal to 0. 0 for x equal to 0 is a continuous function or not. Just like the previous question, there is going to be three cases: before 0, after 0, at 0. Okay. So, since the value of the function before 0 and after 0, whenever 0 is coming and a trigonometry is coming, we better use the H method. Trigonometry and at 0, or whenever trigonometry comes itself, you better use the H method. That is a safe way. So, before 0, what will be the value of the number? Let C be equal to 0 minus h, or x be equal to 0 minus h. H is a very small positive number, therefore h will tend to 0. H is always tending to 0. Okay. So, limit extending to 0 minus of f of x will be limit extending to 0 of x square sin 1 by x, because only at 0 the value is 0. Whenever x is not 0, that is less than 0, greater than 0, the value of the function is x square sin 1 by x. So, limit extending to 0 of x square sin 1 by x, in the place of x, we are going to put x is equal to minus h. So, limit extending to 0 of minus h square sin 1 by minus h. I hope it is clear. Now, h square, if you square h, minus h square, it will be plus h square, and sin of minus theta is minus sin theta. So, this minus sign will come outside. So, limit h tending to 0 of minus of h square into sin 1 by h. Now, remember, h is not exactly 0, h is a small number. So, we know that sign of any number can only be between minus 1 to 1. Okay, sign of any number is going to be between minus 1 to 1. So, this is going to give you, when you substitute here h, it will become 0 square, which is 0, into any value between minus 1 to 1 will give you 0. So, the left hand limit is 0. Let us look at the right hand limit. Right hand limit is also same, but here right hand limit x is equal to 0 plus h. So limit extending to 0 plus of limit extending to 0 of x square sine 1 by x. Here x is equal to 0 plus h. So limit extending to 0 of h square sine 1 by h, same value. So again 0 into any number between minus 1 to 1 will be 0. And what is f of 0? F of 0 is also 0. So the limit value is 0, the value of the function is also 0. Therefore limit extending to 0 of f of x is equal to f of 0. Therefore the function is continuous at x is equal to 0. That was the first case. The second case is when x is not equal to 0. Very simple, left hand limit, right hand limit are both same. So I am going to consider only one case. Let c be any real number. So let extending to c of f of x is equal to limit extending to c of x square sine 1 by x. That will be c square sine 1 by c. F of c will also be equal to c square sine 1 by c. Therefore again the function is continuous at x not equal to 0. So it is continuous at x not equal to 0 and at x is equal to 0. Therefore the function is continuous for every x belonging to R. Is that okay? So please write the previous question, 23rd question and 24th question right now, and then try the 25th question by yourself and then listen to the video. Okay, you pause the video now, copy down 23, 24 and try 25 by yourself and then copy down this question. Okay, I hope you have tried the 25th question. Now I am going to discuss the 25th question. Examine the continuity of f where f is defined by f of x is equal to sin x minus cos x for x not equal to 0 and minus 1 when x is equal to 0. Now look at this question, same model. When x is equal to 0 the value is minus 1, and whenever it is not 0, that means less than 0 and greater than 0, the value of the function is sin x minus cos x. So there are going to be two cases, case 1 x is equal to 0 and case 2 x is not equal to 0. That is in the next page. So what is happening to case 1? When x is equal to 0, limit extending to 0 minus of f of x is equal to limit extending to 0 of sin x minus cos x. Now you may wonder why I have not used h method. It is better to use the h method and see, because whenever trigonometry comes and 0 comes, you better use the h method, but it is going to be the same answer. If you have done h method here, this will be sin h minus cos of minus h. Cos of minus h will be cos h. So this is anyway going to be minus 1. You can try it out if you are using h method. Cos of minus theta is cos theta. So this will get the same value. So I am just substituting 0. Sin 0 0. Cos 0 is minus 1. Cos 0 is 1. So the value will be 0 minus 1, which is minus 1. Now limit extending to 0 plus of f of x will also be the same value. Extending 0 of sin x minus cos x, 0 minus 1. Here also if you use h method, you will get sin h minus cos h. Cos of h, same value you will get. So f of 0 is also minus 1. So limit value and f of value, function value is both same. Therefore the function is continuous at x is equal to 0. Now for x not equal to 0, we have to substitute, let's see, x be equal to some c. So let x be equal to c. So limit extending to c of f of x will be equal to limit extending to c of sin x minus cos x. That is equal to sin c minus cos c. Value of the function is also sin c minus cos c. Therefore the function is continuous for every x not equal to 0 also. Previously we proved that the function is continuous at 0. Now we have proved that it is continuous at x not equal to 0. Therefore the function is continuous for every x belonging to R. Okay. Now 27, 28, 29 are very easy questions. I am going to give the solution later. 26th is a very important question. First I will discuss 26. 27, 28, 29 are easy, but this model 26 to 29 are very important questions. Okay. Now let us discuss the 26th question, page number 161. Okay. Yeah. Find the values of k so that the function is continuous at the indicated points in exercises 26 to 29. Now f of x is equal to k cos x by pi minus 2x when x not equal to pi by 2, and it is equal to 3 when x is equal to pi by 2. This is a very important question, very easy question also. The function is continuous, it is given. All you have to do is make left hand limit equal to right hand limit equal to value of the function. So limit extending to pi by 2 of f of x is equal to f of pi by 2. F of pi by 2, the value of the function at pi by 2 is 3. So limit of the function is equal to 3. You just substitute either left hand limit or right hand limit. Both will give you the same answer. So it is not a proof sum. It is just finding the value of k. So I am using here left hand limit. So let x be equal to pi minus h. H is tending to 0. So see, remember, whenever you have a trigonometric sum and pi minus 2x or pi minus x, all these sums has to be done in this model only. Okay. So left hand limit extending to pi by 2 minus of k cos x by pi minus 2x is equal to 3. And now this limit h tending to 0 of, in the place of x we are supposed to substitute pi minus h. Okay, wherever x is there, just substitute pi minus h. So cos of 90 minus theta is sin theta. So this will be k sin h divided by, multiply the 2 inside, pi minus 2 into pi by 2, 2 gets cancelled, and minus into minus plus 2 into h, 2h. So k sin h by 2h is equal to 3. Take the k by 2 outside the limit because the limit contains only h. So k by 2 into limit h tending to 0 of sin h by h equal to 3. And we know the value of this limit is equal to 1. K by 2 equal to 3. K is equal to 6. I hope you understand this question. Okay. Now before we go to the next question, 27, 28 and 29. Again, these functions are said to be continuous at x is equal to 2. We are supposed to find the value of k. Very simple. Just substitute before left, just substitute 2. So what you will get if you substitute 2 here? 4k is equal to 3 or k is equal to 3 by 4. Very simple question, isn't it? Similarly, for the 28th question, substitute pi in the left hand limit and the right hand limit. So what happens when you substitute pi here? K pi plus 1 is equal to cos pi. What is cos pi value? Minus 1. So k pi plus 1 is equal to minus 1. K pi is equal to minus 2. K is equal to minus 2 by pi. I want everybody to do these sums mentally first. Okay. Pause this video. Try to do 27, 28, 29 mentally and then do it in your notebook. What is the answer for 29th sum? Just calculate and let me know. I will wait for some few seconds. Five k plus 1 is equal to 10, isn't it? 5k plus 1 is equal to 10, 5k is equal to 9, k is equal to 9 by 5. Let us look at the answer. 27, the answer is 3 by 4. 28, the answer is minus 2 by 5. Okay, you can go through this answer. And 29, the answer is 9 by 5. So now we have done all the important problems in the first exercise, and 30 to 34 is remaining, and a few examples are also remaining. That I am going to give you very soon.